In this lecture, we'll be talking about Boy Scout normal form, also known as 3.5 NF. So, it was developed by Raymond, Boyce, and EF Code, hence it's named after their name. The basic criteria is that the table must be in third normal form, that is, it builds upon 3NF, and for any functional dependency A derives B, A should be a super key, or in other words, A should not be a non-prime attribute when B is a prime attribute. Let's do a recap of what we have learned in the normal forms, or rather what violates the normal forms. So if the values are not atomic, we say the table is not in first normal form. In the second normal form, if a part of primary key derives a non-prime attribute, that is, if there's a partial dependency, we say that the table is not in second normal form. In third normal form, we are talking about the transitive dependencies when a non-prime attribute drives another non-prime attribute. In Bcnf, where we talk about slightly advanced version of third normal form, a non-prime attribute can lead us to prime attribute. So a table won't be in Bcnf in that case. Let's take an example to understand the concept. Consider a table where we store the information about projects of clients. Here we have columns client ID, which is our customer, technology, which tells us about the technical stack the client is developing the application on, specialist, which denotes the human resource working on that project, and in the end we have the duration of that project in the form of from date, which is the start date, and to date, which is the end date. Here specialist determines technology as he is supposed to be expert in just one field. Now let's talk about the functional dependencies here. Here the combination of client ID and technology uniquely determines the specialist, from date, and to date. Another functional dependency here is that the specialist can lead us to technology and technology can lead us to specialist, because every specialist is specialist in just one technology. Now there's another candidate key through this relation, that the combination of client ID and specialist can also lead us to the technology from date and to date. So we have two candidate keys and one functional dependency. In both candidate keys, client ID is the common attribute. So these two candidate keys are overlapping. And the from date and to date are the only non-prime attributes. And rest all are the prime attributes because they participate in the candidate key. The table is in third normal form as every non-prime attribute is directly dependent on the complete key and there is no transitive dependency. For Bcnf to happen, we need to make sure that we do not have any determinant other than the candidate key. In other words, it means that 1 and 2 are acceptable, but specialist technology relation is not. For the table to be in Bcnf, we need to take the technology out of the table into separate entity and make a foreign key relation to that. So it breaks down into two tables, that is the client specialist and technology specialist. Now you can see even the redundancy is gone. Now we are not repeating the Bob's name twice with Java. And in this table, the combination of C1, that is the client ID, and specialist, which is the candidate key, determines from date and to date of that project. I hope through this lecture, we are clear with the Bcnf, and in the next lecture, we'll be talking about the fourth normal form. Thank you and see you in the next lecture.